Did computer vision systems mistook turtle for a rifle? Did someone fooled Alexa? Yes, but how and why? I'm your Sue and this is Hello AI. A few years ago, the idea of tricking a computer vision system by subtly altering pixels in an image or hacking a street sign seemed like a more of a hypothetical threat than anything to seriously worry about. Two MIT students presented a framework for making black box attacks several times faster by exploiting information gained from each spoofing attempt. The ability to mount more efficient black box attacks allow engineers to redesign their models to be much more resilient. Actually, these students printed a 3D turtle which the computer vision system mistook for a rifle. These adversarial examples are not bugs but are features corresponding to patterns too subtle for humans to perceive, that all are still useful for learning algorithms. Instinctively, humans are smart. A trained model to identify cats based on robot features recognizable to humans and non-robust features that humans typically overlook, and found that the visual classifiers could just as easily identify a cat from a non-robust features as robust. If anything, that model seemed to rely more on the non-robust features, suggesting that as accuracy improves, the model may become more susceptible to adversarial effects. What about Alexa? MIT came up with a TextFooler, a general framework that can successfully attack NLP system. NLP, natural language processing. The type of system that let us interact with our Siri and Alexa voice assistants and fool them to making wrong predictions. If these tools are vulnerable to purposeful adversarial attacks, then the consequences are disastrous. TextFooler works in two parts: altering a given text and then using that text to test two different languages task to see if the system can successfully trick machine learning models. The system first identifies the most important words that will influence the target model prediction and select the synonyms that fit contextually. This is all while maintaining grammar and the original meaning to look human enough until the prediction is altered. Then the framework is applied into two different tasks: text classification and entailment, which is the relationship between text fragments in a sentence with the goal of changing the classification or invalidating the entailment judgment of the original models. In one example, TextFooler input and output were: the characters cast in impossibly contrived situations are totally estranged from reality. So the output was: the characters cast in impossibly engineered circumstances are fully estranged from reality. So, in this case, when testing on an NLP model, it gets the example input right but then gets the modified output wrong. In total, TextFooler successfully attacked 3 target models, including BERT, the popular open source natural language processing model. It fooled the target models with an accuracy of over 90% to under 20% by changing only 10% of the words in a given text. The team evaluated success on 3 criteria: changing the model's prediction for classification or entailment, whether it looked similar in meaning to a human reader compared with the original example, and whether the text looked natural enough. The researchers note that while attacking existing models is not the end goal, they hope that this work will help more abstract models generalize to new unseen data. So guys, life is either a daring adventure or nothing at all. This is said by Helen Keller. And again, a request: kindly keep a bowl of water before your house or your garden so birds can use it or drink it. So that's all for today, and see you tomorrow. Bye bye.